Okay, anyone to confirm if you are able to see my screen?
I can see your screen, sir.
This is what I was drawing all along. Confirm if my screen is sharing. 100%. 100%. Let me go to what you sent me and then, okay. So the first question was calculate R taught. That was the first question. Number one, it was saying calculate R taught. R taught being the total resistance of the honorable members is that you've already done this. What we haven't gone through is the corrections. So I think for today, I'll be the one doing the writing and the calculations. On your side, you just verify if what I'm doing is the same as what you did. If I'm doing something differently, then we can discuss to check the differences and compare. Okay, so for me, if I have to do the R taught, what I know is that it's only one formula to calculate R taught. And that formula is you must take R1, you plus it with the other R, you plus it with the other R, you plus it with other R's, which may be connected. But you can see that it's only these two and that three which is connected in series, because when it comes to that one and that two, they are connected in parallel because of that wire, it branched when it got to that point. That split, it automatically makes it a parallel connection on that branch. So now it actually means on this formula, I can only substitute that two, I must plus it with this one, which is in parallel connection, I must plus it with a so that I can use to work out the R parallel. It says 1 over R1 of the parallel, 1 over R2 of the parallel. What I do on the next step, it is just to substitute 1 over, what is the R1? It is that one, and then the other one, it is that 2. Trust me when I say the last step is for me to just write R parallel. I just rewrite all of this exactly as it is. And then what I do, it is just to say to the exponent -1. Why did I do that? Can you see here? It is 1 over parallel, but it's not 1 over parallel that I'm looking for. What I'm looking for, it is R parallel. So I took the R parallel and wrote it at the top, 1 at the bottom. Then I know anything over 1 is just that whatever. So whatever that you do on the left, you also do on the right. So this is what does it on the right, mathematically so. So now it means what I'm going to have is just to punch all of that on your calculator. Then what you get is R parallel. 1 over 1 is 1. 1 over 2 is 0, 0.5. So it's like you have 1.5. Yes, you have 1.5. And a 1.5 is 5 over 2. You take 2 to the top and then 5 at the bottom. Then it becomes that. Okay, maybe let me punch it quickly on a calculator before you see anything on the knob. But I know what I'm saying is correct. Let's see. Open bracket 1 over 1, you plus it with 1 over 2, and then you close, then you say to the exponent -1, then it gives you 0, 0.6, 0.666, then you can round it to 2 and say 67, remember to say ohms. Then, now you can continue on that formula where you said 2, you must plus it with the parallel connection, which you've just calculated, which is that you must plus it with 3. trust me, it will give you 5,63777 rounded as far as our parallel is concerned. Guys, please don't be shy to ask me a question on this one. If necessary, you are welcome to take a screenshot on that one. Maybe let me rotate this thing. I'm about to rotate it so that I've got enough space. So you might also need to rotate on your side. But let's see, guys, any questions for me when you were doing this thing? Now I'm listening from you, the honorable members. Talk to me. Guys, are you getting different answers or same as what I am getting? On that question of calculating, taught. Just in case if you've got your script elsewhere, make sure to very quickly check it out and compare.
Same answer, sir.
Same answer. What's your name? Who's getting the same answer?
It's Juanita, sir.
Oh, Takamnisi. Okay. It's fine, Juanita. Very quickly, let me check what was the next question. Very quickly, let me check what was the next question. Three. Okay. So now the reading on ammeter 1, the reading on ammeter 2, and the reading on ammeter 3. Yeah. Okay. This is what I want to say, the honorable members or the members who are honorable. I want to try and relocate this thing because yeah. Okay, let's see if I can. Okay, I can separate. Okay, it's fine. Guys, I want you to be aware of something. Before you can know the reading on ammeter 1 and ammeter 2, you must first know the reading on ammeter 3. So I've made this sequence to check if you can be able to apply your logic on this one. You need to know the total resistance. Then after knowing, the total current, after knowing the total current, then that's when you can get into the parallel current. Okay, so how do we get a ammeter number 3? Ammeter number 3, it is the total current. So you use this formula which says V is equals to IR. What is V? We know it is 15. I is what we are looking for. This is what we just calculated. So can you see, you used R external or R total. It is for that reason why you must use the V total or the V for the whole circuit. It will therefore tell you the current that is flowing externally for that whole circuit. So now it means your current, it is equals to that 15 and you divide it by 5.67 gives you an answer. What is the answer there? You've got 15 that you divide it by 5.67 and it gives you 2.345 says 5. Doesn't end there. You need to say A. This is how you get the reading on ammeter that. So this is the total current flowing in the circuit, which has to split when it gets to the parallel connection. That's how you're going to get your A1 and A2. And you won't have to go through a lengthy process. Why? Because you just need to know for A1, then you will be able to say total minus the one on A1, the remainder, it means is A2. Or for A2, then you will just subtract the total, then on the other one. There are many ways in which you can work it out. You can work it out where you want to know what is the V on that parallel connection, and then you use that V in order to know the current flowing on A1 or A2. The other way, you can use the one for the ratios. The one for the ratios. I'm just not so sure if the one for the ratios is going to complicate things. Maybe let me check. Guys, which one do you find it easy? The one for the ratios or the one where to find one first? Which one works for you guys? Or you also know how to get out it?
So I can't hear you from my side. You're breaking.
It looks like I'm breaking there. Guys, am I breaking for everyone?
Yes, sir. Sure. Let's see. How about now? Is it still breaking? Possibly still breaking. Guys, am I still breaking? No, sir.
It's better now, sir.
Okay. So I wanted to check if you guys are able to calculate using the ratios.
No, sir.
Uh, hmm. Is it everyone who doesn't know how to calculate using the ratios?
Sure. I'm just wondering if it's all of you guys. Who are not able to hear me. Okay, maybe let me try to write something just to give you guys something to think about. Remember, we have a 1 ohm, and again, we also have 2 ohms. So in terms of the ratios, what I meant was if we have 1:2, we add both of these, it becomes 3, then we multiply it by that 2.65. And then again, obviously, we're going to get an answer. And then again, we say 2 out of that total, we multiply it by the. Then from those two answers, it's like we wanted to split this current in that ratio of a 1 ohm and of 2 ohm. Where's the 3 coming from? It is that plus that. It's like we want to see how will it split using that ratio. So let me see, when I punch it on the calculator, the 141/3, it gives 0.88. What is it? Remember here, this is the current, is amperes, current amperes. It was ohm there, the ohms cancelled. It was also ohm there, ohms cancelled. That's why that ends up being ammeter, because you're multiplying with that ammeter. And then the other one, let's see, when it is 2 there, you therefore have 1.77 amperes. Then our conclusion would be on ammeter 1, what we know is that more current should go through the little resistance. So that bigger value will then go to ammeter number 1, and then the smaller value will go to resistance. High resistance, little current. Yeah, this one might be a confusing. I wonder if it is confusing. Maybe let me give a quick example here and say, if, for example, we had 5 ohms, and then the current there, let's say it is 4, what I would do, for example, on this one, it means it is going to be 3 over total, which is 8. Then you just multiply it by 4. You get the answer. Then you go to 5 over 8. You just multiply it by the current. You get the answer. Then from these two answers, the bigger one, it means is flowing through this side because there is little resistance. And then the smaller value flows through that side. Why? Because there is more resistance on that side. Yeah, that's what I actually did there with those decimals. Maybe let me check. When you did it the other way, or whichever way acceptable that you did it, did you get the same answers or did you get different answers? Just says, why is it like I'm disconnected? Yeah. I'm suspecting that I've explained a lot and I'm disconnected. Yo.
Yo. Guys, was I disconnected?
No, sir.
No, sir.
Oh, okay, that's a relief. Were you able to hear me when I was explaining even this second example, this one of 3 and 5? Was I not disconnected?
No, sir.
Oh,
No, sir.
okay. Okay, then it's fine. Okay, now let's see. Mendlonke, I forgot. What did you get? Did you get different answers, or was it the same? Was it these values, regardless of the method that you used? Did you get these values, or was it different answers?
Sir, I only got number 1 for A1 and A2. I didn't get the same answer.
You got different answers.
Yes, sir. On my part. But I believe my answers were
Okay.
wrong because I chose a different method and it got me the wrong answer.
But what if mine is wrong, Mendlonke?
I guarantee you, sir, mine is
How are
wrong.
you convinced? Yo, you sound so confident. Even if I don't sound confident on mine, but the way you sound, yeah, it looks like it's completely out.
Because I chose the wrong method, sir. That's the issue.
Yeah, okay. Maybe let me try to this same thing but differently, using the method that you are most likely to use in an exam, which is one where you need to find a V1. This is how you can do it. And indirectly, you would have answered the other question of V1, because my questions were not in order. I wanted you to just find a way to answer these questions, or to train your mind to be aware that you can only get to certain after you've gone through this. So that means, even if I say, how do you calculate this, and it's the last question, you must find it before you answer what I need you to find. Someone needs to mute their mics. That is the Ma'alis. Ali the Ma'alis. Remember to mute your mic, honorable member. Okay, so now let's see. So the other way in which you can work it out, how are you going to do it, is to find V1. The V1 there. We know the formula for calculating V, it is R. Trust me, the combined resistance that is flowing on that V1, trust me when I say it is 2.65. This is the current flowing on the parallel connection. So this is what I'm saying, honorable members. Remember, you have this. You have that. You also have that. And you have this one of the parallel connection. What is the resistance of that? The combined resistance is what you calculated there as a 0.68. Yes. So that means if you substitute 0.67, yes, 0.67, the answer that you get, it is for that V1, because this V1 is for that. Then once you get that V, you use this V to get into this connection now. So that's why you do it step by step. You start by calculating V1, you use V1 to get into the parallel connection. You just need to be careful when you substitute on this formula to say, if I want V1, the current has to be the one that is passing through that V1, which is the combined, which is that one. And then you will get your V. Then you will use that V to know the current flowing on this side and that side. I hope you guys get my point on that one. Guys, does it make sense what I'm saying?
Yes, sir.
2.65 times 0.67. This is what I'm getting, 78 volts. So that means 1.1. Then now you can use that V1 to calculate the reading on ammeter 1. So that means you'll see 1.78 is equals to, you want the current on ammeter 1. What is the resistance on ammeter 1? It is 1. So that means the current flowing on ammeter 1 is equals to 1.7 divided by 1. It is the same as 1.78. Then this is the answer, but you must make sure that you say amperes. And then again, you use that V1 to get. So obviously, we know this is 1.78, which is equals to, you want the reading on ammeter 2. What is that? There it is 2. So now it's like the reading on ammeter 2, it is 1.78 that you divided by 2. And 1.78, it is that same thing, you just divide by 2, gives you 0.88. 0.88 yes. This is generally the method you would use in an exam where the questions are in order. Let's compare them with that. Yeah, and that one, the reading on ammeter number is that one. Could be the roundings which are a bit off, but it gives you the same answer. So can you guys see? I think you can always use this if necessary, just for you to compare the answers. This is one of the ratio. I think it's easier to just do it and know what you are getting. It's like you are splitting this according to that ratio of that and that. It's like you want to know how much of this pi will go to that and how much of this pi will go to that. Yeah. Indirectly, you've calculated the reading on V1. Now the reading on ammeter 1. I hope I wasn't breaking there. And let me check if you guys have got some questions for me. Guys, any questions for me?
No questions on my side, sir.
But yes, you now understand Mendlong. Does it make sense now?
Yes, sir.
Okay, I think Mendlong is satisfied there. I know Ali Dema Alice has done it that way of the ratios, and he has done it correct. I've checked it, the Alice, you've done it correctly. I just want to check with the other honorable members or members who are honorable in terms of what you have done. Let's see. Anesu Bujani Juwanita Kutlano Mpaka. Are you guys having some questions for me on that one? Or is this a whole lot of pay?
No, sir.
No question.
Good one. Is this all you pay?
No questions, sir.
No further question, you're on. Okay. Then it's fine. At this stage, I won't give you a question to work out, but what I'm expecting from you, it is to then send a WhatsApp to mention the topic that you guys have started with in school. Then in that way, we'll be able to properly plan going forward. So let's see. Guys, did you hear me on that one?
I heard you, sir, but the problem is I'm starting school tomorrow, so I haven't even received news yet.
Oh, okay. No, I see. No, then it's fine. Worry not. If you haven't, you just wait until you start, and then only after you can drop a WhatsApp, not necessarily for this lesson. You got it, most honorable members.
Yes, sir.
Yes, sir.
Okay, goodest. Okay, guys, we'll just leave it here for today. Luckily, I was able to hold for Sir Chris. He might then have to take the Thursday's lesson. Otherwise, guys, do thank you very much for joining. Even today, my name starts with a letter D, as in Pumila Manch.